Hey everybody, Trey here. Welcome back to another video. Back with a unique forecast discussion for today, as the SPC has highlighted a level 2 out of 5 slight risk for parts of western Oregon and Washington. Not something we say very often, but there is quite an elevated severe weather risk out there today, and the greatest risk is going to exist in the yellow shaded region here. That's that level 2 out of 5 slight risk. And so we're going to take a look at the setup today. Very unique setup for this area. Quite the elevated severe risk for this area. So some interesting things to discuss with the setup today. The greatest risk is going to include the yellow shaded region here. So Seattle, Tacoma, Olympia, down toward Portland, Salem, Eugene, and areas in between. You are in that greatest severe weather risk for today, with a large marginal risk level 1 out of 5 extending over toward the Oregon and Washington coast, off to the east, all the way into parts of Idaho. So the risk does extend quite a ways off to the east. Not as great of a risk out in here, given a lot less moisture, a lot drier air out there to the east. So could see just a few damaging wind gusts out in that area, but most of the severe threat is going to exist in the yellow shaded region here. That is going to include a risk for all severe hazards. The tornado risk is pretty elevated for this part of the world. 5% tornado risk down there, basically just south of Tacoma and Olympia, including Portland, Salem, and Eugene, in the 5% risk there. 2% surrounding that, including Seattle. So really unique to see this kind of an outlook up here in this region. I think this tornado risk is not going to be the main threat for today. I think that is going to go to the large hail risk. There is a 15% hashed risk in the yellow stippled region you see here. That means the threat is there for a few hailstones in excess of 2 inches in diameter, which is, again, pretty unheard of for this region. But that includes Seattle, Tacoma, down to the south, Portland, Salem, and areas off to the east. And that is going to be really the main threat with today's storms that develop in this region. Damaging winds also going to be a risk, but the main threat going to be for large hail and perhaps a few tornadoes. So very interesting setup. Let's go ahead and dive right in. We're going to start with our water vapor satellite imagery for today. Unfortunately, the SPC mesoanalysis does not really have a sector that covers a little bit out there into the Pacific, so we can't really get a good picture of this storm system from just the mesoanalysis data. So we're going to look at our 500 millibar data here in just a second, overlaid on this water vapor satellite imagery. This is water vapor satellite imagery, and it shows basically the moisture in the atmosphere. And right away, your eyes are drawn to this swirl right here, just off the Pacific Northwest coast. Very much some satellite eye candy here. Very wrapped up cyclone here. As you see, very strong swirl there in the flow, lots of moist air rounding the eastern side of this cyclone. And this cyclone is going to really kind of spin off to the east a little bit. And the exit region of this trough is going to impinge upon that western Oregon and western Washington region. Let me go ahead and put on our 500 millibar contours here. Unfortunately, these are cut off as well, but at least we can get a good picture of kind of the eastern half of this trough. So you see here, the trough centered right over here, right where at the center of that swirl, and these red contours are our height contours, wind barbs drawn in as well. So very impressive looking exit region to this trough. Lots of defluence in the exit region of this trough. That's when those winds spread apart in the upper levels of the atmosphere. That allows for a void. Mother Nature doesn't like that void. That brings air up from below to fill that void and give us that rising motion we need to initiate storms in a given environment. And we've got that in spades today. Just a very textbook looking cyclone here off the Pacific Northwest coast. Again, this exit region is going to start to slowly meander off to the east-northeast today, placing itself over that western Oregon and Washington region by about mid to late afternoon, allowing for ample forcing for ascent and ample rising motion to allow storms to initiate here, especially with the help of terrain on the coastal ranges and the Cascades there. That valley in between might be that spot to be, especially for that tornado risk. That tornado risk is quite narrow, kind of encompasses just that valley in between the coastal ranges and the Cascades there in western Oregon and Washington. But overall, very impressive system here. I'll take this off here just for a second so we can play this loop again. That is just some satellite eye candy this morning. Pretty textbook looking trough, closed low. It is a closed circulation aloft. And there's also going to be a lot of cold air aloft with this system. Very cold air aloft at the center of this system, going to start to overspread the region, help to really steepen those lapse rates aloft, and provide for really regionally very strong instability here. in the plains, it's kind of just a run-of-the-mill thermodynamic profile, and you'll see that here in a second. But for this region, we're going to have plenty of instability today to allow those lapse rates to really steepen aloft and give us some robust updrafts. Let's take a look at the surface here on our SPC mesoanalysis page. Again, it's a little bit difficult to really get the fine-scale details here, as the much of the Pacific where this system is located is kind of cut off. But we can at least get a little bit of a look here at the overall surface pattern. Looks like the center of the surface low is somewhere out in here, just off the screen there. You see the isobars kind of tightly packed in here. Looks like perhaps a little bit of a frontal zone draped across here. A couple of little pressure tongues in here. A little bit difficult to ascertain without, again, seeing the full picture here. But this surface low is going to meander off to the east. We may see a little bit of redevelopment out here as that stronger flow traverses the higher terrain of the coastal ranges and the Cascades here. So we may get a little bit of surface low development, or at least redevelopment out here across the western Oregon and Washington corridor, helping to perhaps keep those winds, especially in that valley, out of the southeast. That could be a favored area for tornadic supercells, given a little bit more backed low-level flow, just like the Sacramento Valley, the central valleys of California do the same thing. It kind of funnels that flow off to the southeast, and so you have stronger low-level shear, stronger low-level vorticity to be stretched by those updrafts. That may be the same thing up in here, especially within that valley. Portland southward toward Eugene, Corvallis, that could be the same phenomenon there. So that is kind of the surface pattern there. Not really much else to see. 850 millibars. You see we do have a nice low-level jet here just off the coast at this point, 30 to 40 knots of flow. That is expected to move inland and kind of perhaps just bleed inland a little bit there. Of course, we have a lot of terrain interactions here. How will that impact the low-level flow off to the east, especially within that valley? But if we can get that kind of 30 to 40 knot low-level flow here at 850 millibars into that region, that's going to provide for a lot of low-level shear, at least enhanced for this area, to provide for somewhat of an enhanced tornado risk there. Let's go out to the surface, our raw surface data here. And you can already see fairly decent moisture, especially for this region, already impinging upon this corridor. Dew points in the low to mid 50s out here from across the coast and just inland as well. Portland there at 56 over 49. Down to the south, Eugene 50 over 49. So those dew points looking pretty good for this region, and we're going to continue to get some moisture here. That could even pool within this valley, just between the coastal and the Cascade ranges there. Could get a little bit of moisture pooling within that valley. Dew points perhaps even up into the mid 50s or so, which for this region is pretty high, especially for when we have a severe weather threat that we're talking about. Winds fairly quiescent here. I would expect those to strengthen as that surface low starts to perhaps redevelop, or at least move off to the east a little bit. Should get those winds again out of the south or southeast to help increase that low-level shear ever so slightly to produce that tornado risk this afternoon. Taking a look at our Seattle sounding here this morning, and pretty impressive already for this region. This, if I didn't tell you this was Seattle, you might think, oh, this is a decent-looking sounding for the morning of a severe event out in the plains. And you would be right. This is pretty impressive here. 56 over 54 at Seattle here this morning at 12Z, so 7 a.m. Central Daylight Time. That's going to be 5 a.m. Pacific Time. Very steep lapse rates aloft already. This is kind of mimicking an elevated mixed layer here. I don't know if it's actually a true elevated mixed layer. Not really sure where it would come from, but very steep lapse rates aloft here from basically about 900 millibars upward. Which is going to persist into the afternoon today, perhaps going to get this little bit of warmer air up here aloft to cool when that cooler air from the trough starts to overspread the region. And we're going to see quite a bit of instability here. We don't have much at this point, a little bit of elevated instability above that warm nose, but once we get that cold air to come in, coupled with this steep lapse rate layer already in place, we're going to have a very deep layer of steep lapse rates, and that's going to lead to pretty robust instability. Would not be surprised to see 1,000, even 1,500 joules per kilogram today, which is pretty strong for this region. Again, not super strong for out in the plains per se. That's kind of a run-of-the-mill thermo profile for elsewhere in our typical areas of severe weather. But for the western Oregon and Washington corridor, that is pretty impressive. So thermodynamically, not going to be an issue today at all. Wind shear we already have enough bulk shear, strong deep layer shear at this point, about 40 knots or so of deep layer shear. Low level shear again is pretty weak at this point, very minimal low level flow, but as that surface cyclone, low level cyclone creeps inland and perhaps starts to redevelop, we should get a little bit of enhancement at least in the low level flow here, perhaps backing those surface winds out of the southeast, providing a little bit of extra low level shear. And I assume there's going to be a lot of vorticity in this region, given all the terrain features at play. Coming from Arizona, I know this very well. In some of our more robust severe weather setups out there that involve supercells, the low-level photographs weren't all that impressive, but you have such impressive, such intricate terrain interactions out there that you can have the strong low-level vorticity off these terrain features. Let's just go ahead and take a look at that 0 to 3 kilometer cape here off to the east. You see some of that vorticity pooling there. This is going to be valid in 6 hours, so 20Z right before storms fire. You see a lot of those blue contours there across Oregon and Washington, and that's probably due to the terrain. So if we can get a little bit of stronger low-level instability, which we should, that could be helpful to stretch that vorticity into the vertical to aid in tornadogenesis, even if low-level shear is a little bit on the weaker side today. All right, let's take a look at our model data. We're going to start with the 6Z GFS. Again, unfortunately, the NAM, which is a little bit higher resolution model, does not have a sector that gets us out here into the Pacific enough to see this entire system. So we're going to have to use the 6Z GFS here, but it should be okay. We're kind of right at initialization, so this should be okay. So this is at 500 millibars, and here is our trough out here just off the Pacific Northwest coast. Very robust trough, nice negatively tilted trough. Closed circulation there at the center, so this is certainly a closed 500 millibar low. Going to continue to meander off to the northeast today, and as we go into the kind of mid-afternoon hours, that exit region within this trough is going to start to overspread portions of western Washington and Oregon, allowing for that rising motion to overspread the region, and that is going to allow for storm initiation to take place. Let's go ahead and look at the temperatures here at 500 millibars. You see all of this gray at the center of the 500 millibar closed low. That starts to overspread the region by mid to late afternoon. Those grays start to bleed into the onshore there by about 21Z. So this is going to be 4 p.m. Central Time, 2 p.m. Pacific Time, and that continues to overspread the region going into the late afternoon to early evening hours, and that is going to again help to really steepen lapse rates aloft to allow for some strong instability across this region. Let's zoom in here, use our 12Z NAM now, taking a look at our surface pattern. You see here as we go into the afternoon, perhaps a little bit of a surface low center develops across perhaps more so western Oregon, keeping those low-level winds out of the south. Not particularly backed winds here on this individual NAM run, which makes a little bit of sense just given the orientation of the valley, but if we do get a little bit more southeasterly component to the winds out in here, even up in here across southwest Washington, you see a little bit more backed flow up in here. That could be the favored area for some tornadic activity. It's just going to depend on where that low-level shear is strongest and where that vorticity can be stretched into the vertical to aid in tornadogenesis in some of these supercells. So we go into the afternoon, and that low kind of moves off to the east. Winds veer quickly off to the west of the surface low center, and then off in front of that surface low, we see some nicely backed flow. The problem is that, again, the moisture out here is going to be a lot weaker than it is off in that kind of the region of that valley between the coastal and Cascade ranges. Let me show you what we're talking about there. Here is our surface moisture. We go on into the afternoon. We see some, again, nice pooling of the moisture, some 50s and even some 60s dew point readings up in here. That could be a little bit high. The NAM does have a bias there toward a little bit more moisture than reality dictates here. So this may be a little bit high, but we could see easily dew points, in the 55 to maybe 58 degree Fahrenheit range there within that valley. But you can see it is really pooled nicely in that valley, kind of south of Tacoma and Olympia, down toward Oregon, Portland, Eugene, down toward that region there. So that is going to be a nice little corridor there with some enhanced low-level moisture. But out to the east, you see dew points hanging out in the 40s. Temperatures expected to get into the mid-70s at least there, so that's going to lead to very high temperature dew point spreads. So any convection there will be mostly a damaging wind threat. A few damaging wind gusts expected out that way, and the other risks, the tornado and large hail risk, going to maximize where this low-level moisture is maximized as well. This is at 21Z, 2 p.m. Pacific. We're going off into the evening hours. You see that moisture maintains itself, some low 50s dew points out in here, so that could allow for some storms there going into the evening hours, and then things dry out going on further on into the night. So let's take some soundings here out across this region. We'll take one here, maybe up toward Tacoma, then one down to the south there, maybe toward western Oregon there, and we will see what we see here. So this is going to be the Tacoma area, 21Z, 2 p.m. Pacific time, and this is pretty impressive for out in this region. I keep saying that, but it's pretty shocking to see these kind of profiles out in western Oregon and Washington. Look at this thermodynamic profile. Again, you'd think this was out in the plains. If I didn't tell you this was western Washington, you'd think this might be a plains type thermo profile. Very steep lapse rates aloft there. You see the slope there in that 500 there, in that temperature profile there, between about 850 and 500 millibars. Very steep lapse rates aloft, approaching, you see there, 0 to 3 kilometer lapse rates, 8.3 degrees Celsius per kilometer, 850 to 500 lapse rates, 7.5 degrees Celsius per kilometer. That is very impressive, very steep lapse rates aloft, leading to nice, thick, fat cape here. That cape profile not skinny in the slightest, so that is going to allow for really robust updrafts. You can use the word explosive for this region perhaps. Only about 1,100 joules per kilogram mixed layer cape. But again, I wouldn't be surprised if that even gets locally higher, up toward that 1,500 joules per kilogram mark. But overall, nice, more than adequate instability for this region. Fat instability at that. And we do have a little bit of low-level instability as well, 63 joules per kilogram, 0 to 3 kilometer cape. And 71 over 61 at the surface. Again, I think that dew point is a little bit on the high side. Probably going to see something in the maybe upper 50s, so maybe 71, perhaps a little bit warmer than that, 73, 74 over 58. Still adequate within that 20-degree threshold for tornadic supercells. So thermodynamically, this setup is not struggling at all. Kinematically, very impressive as well. A little bit of curvature there in the low levels of the hodograph. Nice veering and somewhat strengthening of the winds there in the low levels with height. Strong deep layer shear, over 40 knots of effective bulk shear there. So long hodographs with some curvature in the low levels could lead to that tornado risk out there from Tacoma southward this afternoon. Farther south into western Oregon, much of the same thermo profiles, a little bit more drier air in the low levels there as depicted by the NAM, and a little bit worse kinematic profile there. Not quite as much veering and strengthening of the winds in the low levels with height, but still strong deep layer shear, slightly stronger winds aloft here, leading to about 60 knots of effective bulk shear there. So that could lead to that will be an environment very favorable for supercells. Now, the flow aloft, one thing to note, the flow aloft is fairly meridional here, which means more south to north. So oftentimes in these more meridional flow setups, that tends to lead to a bit more upscale growth in the convection here. So, to be honest with you, I'm not 100% sure what our initiating boundary is per se. It might just be the terrain features out in here. And so, if we assume that valley, the ranges here in the valley situated more north-south, you have flow aloft and your deep layer shear vectors oriented more along, more parallel to those boundaries. That is going to lead to perhaps some upscale growth, perhaps a little bit more supercellular activity in the first few hours of the convective life cycle, and then I think we'll see perhaps a little bit of upscale growth into more clusters and line segments here moving off to the north with some perhaps mixed supercells mixed in. But the storm mode could be a little bit on the messy side eventually, but I think we will see a window for some supercells in this environment, especially with such strong deep layer shear to help organize that convection. Let's go to 0Z, so this is going to be, 5 p.m. Pacific time. We'll go there just south of Seattle, then down into the western Oregon vicinity. So this is going to be up to the north, very strong instability. You see here the NAM, this is probably too high, of course. The NAM has a bias in that regard, but almost 2,000 joules per kilogram mixed layer cape. Very fat, low-level instability. If that, even half of this comes to fruition, half of that 200 joules per kilogram, 0 to 3 kilometer cape, if even half of that comes to fruition, that would help to aid in the tilting and stretching of vorticity underneath these updrafts. The wind profiles, again, for a typical plains type setup, not really all that impressive, but for up in here with some strong low-level flow, that is going to be perhaps favorable for some tornadoes there going into the late afternoon to early evening. They're in western Oregon, a little bit convectively contaminated, so we'll throw that out. But overall, strong thermodynamics here with this setup, strong kinematics, and we may have that little bit of extra oomph from the vorticity stretching, given strong low-level instability. Let's take a look at some cams here. So this is the 12Z HER out across this region here. So you see here we go into the mid-afternoon hours by about 22Z or so. First signs of convective development. I would take a couple hours off this. The HER is usually a little bit slow, but you see here, nice little band of some broken supercells here. One in particular, very robust storm on this model. They're just in northwest Oregon. These storms are going to be moving off to the northeast. And you see here a mixed bag of convective modes, some clusters, some lines in there. I think this might be a little bit too quick of a transition to more of a clustered mode. I wonder if the profiles here across these areas on the HER are a little bit too well mixed. Actually, not really. 72/60 here with the HER. The HER has a tendency to overmix the environment, cratering those dew points. Not the case here. So perhaps it is that more meridional flow aloft that kind of clusters things out eventually. But we see here the more robust storms do tend to favor a little bit more northern areas of the risk, kind of northwest Oregon up there toward the Seattle-Tacoma area. Later on, some more robust cores up in there, whereas down to the south, a little bit more clustered, not quite as strong reflectivity on this particular run of the HER, and then things kind of spread off to the east going into the evening hours there into central Washington. See if our other models are in yet. 12Z WRF ARW. So we see here 22, 23Z storms start to fire. There are not a ton of robust helicity streaks in this activity, but again, the more robust cores do look to be kind of northwest Oregon up toward the Tacoma, Seattle area. So it looks like the northern portions of the risk may be favored for some slightly more robust storms, at least with these first few cam model runs, at least these first few cam runs. Let's see the NSSL WRF. And then we see, so here, NSSL WRF a little bit more robust. We see a couple of helicity tracks up in there, southwest Washington. But again, most of your more robust activity or more robust reflectivity up here, northwest Oregon to western Washington. So certainly an interesting setup for today. The models are pretty much on board with how things are going to progress. Again, slight risk, level 2 out of 5 out here for western Washington and western Oregon. Again, I think the favored area for slightly more robust storms looks to be a little bit more on the northern half of this risk, northwest Oregon into the western portions of Washington. That includes Seattle, Tacoma, Olympia, down toward Portland, with that slight risk extending all the way down to Salem and Eugene, perhaps Corvallis there in the level 2 out of 5 slight risk. I think storms will be perhaps supercellular initially, then we'll get a more mixed bag of convective mode, some more clustered storms, more line segments with some supercells mixed in. But still that threat for tornadoes and large hail will be maximized across this slight risk corridor. Tornado threat is greatest within that valley there between the coastal and Cascade ranges. 5% tornado risk extending up basically almost to the Tacoma, Olympia area, southward, Portland, Salem, Eugene, all in that 5% risk, with a 2% risk extending up to Seattle, up there in western Washington. And then large hail, again, I think large hail going to be the main risk for today. 15% hatched area, the threat for some large to very large hail, perhaps 2 inches in diameter plus, up in this region, Seattle, Tacoma, southward to Portland, Salem, Eugene, and then into the Cascades. That is going to be the main threat with the storms today. Then a few damaging wind gusts are possible as well, especially with any more line segment type activity, more clustered storms. And then as storms move off to the east, going into the evening hours, towards central Washington, southward into Oregon and Idaho, could see some sporadic wind gusts in that. So all in all, a very potent setup for the region, very interesting setup to take a look at. Certainly an all hazards threat on the table for today with some of those supercells. Not something you see often in this region. So folks up there in Seattle, Portland, Eugene, Corvallis, definitely take heed of all warnings today. This is going to be, for your region, this is a pretty robust risk. So take all severe thunderstorm warnings and tornado warnings seriously. and have a plan in place if you are in these areas, just in case severe weather does head your way. So with that, thanks for watching, and we'll see you in the next video.